We are now solving question 2 of the topic work power energy for AS level mechanics. P and Q are fixed points on the level of the greatest slope of an inclined plane. The point Q is at a height of 0.45 meter above the level of P. A particle of mass 0.3 kg moves upward along the line of the slope PQ. Part 1. Given that the plane is smooth and the particle just reaches the point Q, find the speed with which it passes through the point P. Second part, it is given that instead of the plane is rough, the particle passes through P with the same speed as that was found in the part 1 and just reaches the point R, which is in between P and Q. The work done against the frictional force in moving from P to R is 0.39 joules. Find the potential energy gained by the particle in moving from P to R and hence find the height of R above the level of the point P. So we are going to solve this question for the work power energy. There is a line PQ and there is no frictional force, so F is equal to 0. The speed at P we are going to find out, let's say that is u meters per second, and at the final it is equal to 0 because it is just going to reach at the point Q there. This point Q is on a height of 0.4 meter above the level of P there. And we are going to find out the value of U when it is going to move upward. We know one thing, that we have the two formulas for this part. Formula number A is loss in kinetic energy is equal to gain in potential energy of that particle at the point P and at the point Q. Or mechanical energy at the point P is equal to mechanical energy at the point Q. This is initial or equal to the final state of that part there. So we can use any one of these two formulas there. If we use this formula A, loss means negative. So we will use for loss word initial then minus final. So it should be equal to half m u square minus half m v square. It is loss in kinetic energy equal to the gain in potential energy, that is mgh. So here m is cancelled out in all the parts. Now we put the values half into u square, you are going to find out minus 0 is equal to gh, or u square is equal to 2gh. So here it is 2, g is 10 and h is 0.45. So u square is equal to 9, or u is equal to 3 meters per second. So this is the speed due to it will leave the point P there. For the second part, this is the point P, this is the point Q, and we know that R is in between P and Q there. And The speed at this point P, as it is used in the part 1, so it is equal to 3 meters per second. And it is just going to reach at this point R, where its velocity will be equal to 0, because it is just reached there at the point R. And the work done against the resistive force, which is basically equal to 0.39 joules. Because there is no angle given here, so we can directly use the concept of this potential energy. So we can have this famous equation, always use this part, that work done by driving force minus work done by frictional force is equal to change in kinetic energy plus the potential energy. And this thing we are going to find out, which is equal to mgh there. But we know one thing, that because there is no driving force applied on this particle, so it should be equal to 0, minus work done by the frictional force is equal to 0.39 joules. So that is equal to 0.39 is equal to half m is there, which is equal to 0.3 into v square 0.3 minus 9. So it is basically equal to minus 0.39 plus 0.15 into 9, and that thing is equal to the potential energy which is gained by this particle when it is going to reach at the point R is equal to 0.96 joules. In the last part, they are asking find the height of that particle above P when it is just going to reach the point R there. So let's say this is point P, this is point R, and it is at a height of h1 meter above the level of the ground. And we know one thing, that the potential energy from P to R is basically equal to 0.96. So that thing is equal to 0.96, and we know that potential energy is equal to mgh1. So mass is known to us, that is 0.3, into g is known there, that is h, and that is height h1. So h1 is basically equal to 0.96 over 3. So that thing h is equal to 0.32 meter above the ground of that level P there. So this is a complete solution of this problem, where first we are going to calculate the velocity due to which it is going to pass from the point P with the help of this concept, with either the loss in kinetic energy and gain in potential energy, or you can even use mechanical energy at P is equal to mechanical energy at Q. Second part, there is a frictional force. So when there is a frictional force, it is given there, the work done by the frictional force is 0.39 joules. So we can use this equation of motion there. And last is the height. So we can use the potential energy and we can find out this height from that part there, which is equal to 0.32 joules.